Let's talk a little bit about collections in C#. And we'll start by looking at a program that you see here called List and Dictionary. So we're looking at the program file associated from that project. And as we look at it, we see that one of the using directives is for a namespace of System Collections Generic. So if we go into the object browser and we search for System Collections Generic as a namespace, what we'll find is that namespace is split across 4 different assemblies, like MS Core Lab and System. And in that namespace, what we're going to find are a number of classes and other resources associated with creating collections of things. In other words, things like lists and queues and stacks. So we can take a look at that pretty easily. For example, here we see the class associated with the collection dictionary. And here we see the class associated with list. Here's the class associated with hash sets. Here's the class associated with linked lists and with queues. And you can take a look at some of these other things that are inside of this namespace, which, as I said, in our case here, is spread across 4 different assemblies. So these collections allow us to, as the name implies, collect data together and manipulate it in particular ways, for example, like a queue or a stack, which have different behaviors, but all store items of some class. So the ways these particular classes do their jobs is with generic parameters. So these, of course, are generics because they come out of the namespace System Collections Generic. And a generic is essentially something that takes compile time parameters. So you can see the example here of using the class list, which is to say the generic list class, which takes as a parameter the data type of the things being stored on the list. And this, like all generic collections, demonstrates the power of separation of concerns. In other words, storing a list of integers is conceptually exactly the same as storing a list of doubles or storing a list of floats or storing a list of any class, object, or whatever it might be. So we separate the storage of the data from the data itself. And what that means is that we only have to write the storage for a list one time, and we can reuse that code over and over again by passing it different compile time or generic parameters. So once again, we're not repeating ourselves, we're not repeating our algorithms. I'm only going to write that code one time and use it over and over again. And that's the power of generics. So here we have a simple creation of a list object, so its data type is list, and then the compile time parameter for that is int, so this is read list of ints. And we want to create an object of that class. And so although the syntax seems strange at first, it's really completely consistent. The data type of, in this case, scores is list of ints. And so when you construct it, you use a constructor with exactly the same name. And you can add things to that list, and you can remove things and various other operations. And because this is a list, they've added an indexer property, which allows us to treat the data in this list as if it were an array. So index by 0, index by 1, that sort of thing. There are any number of simple operations associated with a list, and among those is the ability to treat the list as if it were an array, but with considerably more flexibility and more operations. So the other collection we're going to look at here is dictionary. And dictionary, as you can see, takes 2 compile time or generic parameters, T1 and T2. So we're creating a dictionary object indexed by color of double. In other words, this is a collection of things whose index value, instead of being an integer 0, 1, or 2, is actually an enumeral of the enumerated type color. So we can see that up at the top. So here's my enumerated type color, which has the enumerals red, green, and blue. And so I create my dictionary indexing the values of the dictionary by color. In other words, the index values of this particular dictionary will be red, green, and blue, and then the values of those indices will be doubles. So this is the data type itself. So this is a dictionary indexed by color of double. And once again, we create an object in the same way. So the data type is dictionary color double, or as I said, dictionary indexed by color of double. So we can then add things to our dictionary, giving it the index, in this case, the color blue, and the value 4.4. And as you see here, once again, we have added an index property to dictionary so that we can use the square brackets for index values. And in this case, because we are indexed by color, then that means the thing in brackets would be a color, a numeral, in this case blue. So we're saying, for example, that the dictionary value under the index blue is 5. And then we can manipulate that data in various ways based on that index value. So for example, here we have a for each loop. So for all of the colors in the paint store keys, so the paint store keys would be all the values of the enumerated type color, which is to say red, green, and blue. We want to print out that color and then the paint store's value at that index. So that's looping through all of the key values. Or we can simply loop through the entire dictionary, and in that case we have a value, and that would be the double value, and we have the paint can key, and that would be the enumeral of class color. Note the use of the var keyword here. We are allowing the compiler to infer the data type that's necessary for paint can so that we can get a paint can value and a paint can key. So that's a couple of ways to iterate through a dictionary. So now if we run the code, we see that we have the values 94 and 55, and that was scores sub 0 and score sub 1. And then we have the second for loop that prints out first the enumeral and then the value associated with that enumeral. And that goes through 2 times because we added 2 colors with 2 associated values. And then we have the last for each loop that just iterates through the dictionary by its element, which is composed of a value and a key. So here's where the value is printed out, here's where the key is printed out. And that's collections in C#.